Hello, everyone. Welcome to another talk on Crowdcast, where we are going to be talking about how to deploy NFTs on Celo as part of the Make Crypto Mobile Hackathon. My name's Josh, and yeah, as I said, I'm going to be talking about NFTs on Celo. So yeah, I do developer relations with C Labs. So I'm really helping developers build successful products and services on Celo. A big part of my job is education. So I'm hosting office hours, I think three hours per week throughout the duration of the hackathon. If you guys are on Discord, you can find the event information bar on the left side at the top. I'm adding all of our office hour events there, and we're just having office hours right in Discord. You can ping me directly with questions. You can tag me. My handle is just Josh C on the Celo server. So yeah, with that, I'll just jump in. And if you guys have questions, my colleague Joe is here. He can help flag questions to me. And let me just turn off my notifications so we don't get disturbed. Yeah, and I'll start sharing my screen. I've got a deck that I'll go over for the beginning, and then I'll share my screen and kind of show some NFT examples that I've deployed onto Celo and how you guys can do something similar. So with that, I'll start sharing. All right, NFTs on Celo. I think to start, we should just go over what NFTs are, provide some context about what we're talking about building and why it might be interesting. So NFTs are non-fungible tokens. Non-fungible tokens just means there's a representation of, there's a token on a blockchain that is unique. And that's basically the simplest term. This often is in contrast to fungible tokens, which are used more like a currency where all fungibles are essentially interchangeable with each other. So like Celo is a fungible token, or Celo dollars are fungible tokens, where one Celo is indistinguishable from any other Celo. Likewise with Celo dollars. Whereas with non-fungible tokens, there's actually unique identifiers associated with these tokens. So these tokens are not interchangeable with each other. And these blockchains like Celo and Ethereum and other EVM chains, or any smart contract chains, are they're created through contracts, just like how fungible tokens are. When we're building on Celo, we use the Ethereum standards that have been developed over the past years. Like you may have heard, like ERC 721 or ERC 1155. Those are non-fungible token standards. ERC 20 is the fungible token standard. So a lot of EVM chains are just adopting these token standards because there's a lot of interoperability with them. But they're essentially just simple smart contracts that are deployed on chain. And with an NFT contract, like with an ERC 20 contract, the contract just stores the entire collection of the token. So like with ERC 20, like Celo dollars, there's just a contract that stores all of the accounts that have Celo dollars and then the corresponding balance for those. And then if you ever send those anywhere, those balances are updated. So the recipient and the sender's balances are updated when you do a transfer. The same thing is done with an NFT contract, where when you're sending NFTs, there's similar transfer functions, approve functions, but there's some additional functions with an NFT contract, and additional storage state variables in the contract that define what those tokens actually are, how they're unique, and then the ownership of them. So one thing that makes NFTs different than ERC20s or fungible tokens in the actual smart contract is the tokens in the smart contract actually reference off-chain immutable storage. So they often do. They're not required to, but pretty much all of the most interesting projects that I've seen are referencing off-chain immutable storage. So they're essentially just hash pointers to off-chain data. And usually this is on like IPFS or Arweave, where in the smart contract, in the token metadata, there will be a field that says this token metadata can be found at this IPFS hash. And then any software that's looking at the NFT information can then look up the corresponding metadata at that IPFS hash or the Arweave hash. So that's a super important, like, unique feature of NFTs, and this is where like a lot of the power of NFTs comes from, because in that metadata file, there's a lot of flexibility in terms of what data is stored there. So what we've seen people building with NFTs and like what's possible with NFTs, we've seen a lot of art and music and PFPs or personal profile pictures like CryptoPunks or Bored Ape Yacht Club or Celo Punks. But like really almost anything you can imagine being represented with NFTs. So in Celo, we're talking about putting natural capital resources like in our reserve that actually back our stable currencies. And in the long-term vision of that, we actually want to help, like, we want to tokenize forests and actually put forests and like clean natural resources in our reserve, because those are things that society values and that we think should also back our currencies. But to actually get those into the reserve is really difficult. There are some projects that are starting to tokenize forests, but it's a really hard problem. But it's easy to imagine how like a parcel of a forest tokenized could be valuable, because then we can actually create this digital representation of it and then interact with it, engage with it in our blockchain systems. So that would kind of fall under this legal documents, maybe like a form of a legal document or an ownership document, and anything part of the forest. Also, certificates of ownership kind of falls along the same idea. But this can be like really any ownership title or like representation can be tokenized and put on the blockchain. So talking about NFTs on the EVM. I mentioned ERC20 standard, ERC721, these Ethereum standards that have also been adopted on other EVM chains like Avalanche or Phantom. And the advantage of using these standards that have been developed elsewhere is like we don't have to do it again. There's already like wide agreement on what these standards are, and we can kind of just like build off of the previous work. So we can reuse a lot of the code that's been developed. We don't need to rebuild infrastructure. We can have NFT marketplaces just add support for new chains, which is much easier than having basically building entirely new marketplaces from scratch. Then we can also kind of build off of people's experience with NFTs in terms of how they're understanding how NFTs work, how these marketplaces work, what they can expect in terms of interactions, or maybe in like more experimental domains where NFTs are actually being fractionalized and you can have like a part ownership of a expensive NFT. Doing that and building off of existing standards will be much easier for new projects, rather than kind of doing it their own way each time. So this kind of coalescence around the EVM and the standards there is actually the community at large. And then when we start building and deploying like new forms of NFTs, like on Celo, if we have a new NFT project that hasn't been done on any other chain before, that finds a lot of success, then other chains that are using the same standards can also take advantage of the developments and the success that has happened here. So it's a win-win for everybody. It's also easy to imagine, like with the the multi-chain future and like integrating with multi-chains. I kind of touched on it with thinking about how marketplaces can support multiple chains, but with more bridges that we're seeing between chains, it's easy to imagine how NFTs will behave differently on different chains. Not behave differently, but like people will use NFTs on different chains in different ways. So like on Ethereum, it's expensive to an NFT right now. It's quite expensive to transfer NFTs. It's expensive to do everything. We're starting to see NFTs being like more NFT action on other chains. One of the big problems we see with bridges and like the DeFi space is like just getting liquidity across chains. We don't really have this problem with NFTs because there isn't the concept of liquidity in the same way that there is with like more capital based tokens that are acting as currencies. So if we have an NFT that's minted on Celo and then is transferred to Ethereum, it's almost the same. I mean, it is the same thing. It's a representation that has the same information there. So thinking about how NFTs are bridging between chains is quite a bit different than thinking about how fungible tokens are bridging between chains. And I think it will almost be easier once we have infrastructure in place to think about how NFTs are moving between chains. So we might see NFTs moving between chains for different reasons. Maybe I'll keep my NFTs on Celo because I'm aligned with the mission of Celo and I want to take advantage of the like DeFi and mission aligned projects that are built on Celo. Cost will likely be a factor as NFTs start moving across chains. Transferring NFTs around on Polygon or Celo will be much cheaper than transferring NFTs on Ethereum mainnet. So it makes it kind of less interesting. If you have NFTs that can't move around and can't interact with other projects on chain, it's not as fun. Also, just like what communities are on different chains. What do I want to signal to the communities that I'm participating in with my NFTs? That's important to consider. And also this idea of like collaborating with other layer one projects. One of the really cool things about Ethereum right now and why it's so expensive is like every layer one application on Ethereum can just natively interact with other protocols. So I'm thinking about DeFi specifically with like money Legos. DeFi across chains is much more complex and difficult than DeFi on the same chain. This is true with NFTs as well. So if we have NFTs that want to be fractionalized and have part ownership and then participate in a marketplace, and then also like maybe that gets you membership to a DAO. If all of these things are happening on one chain, it's much easier to compose these parts together to build new interesting projects as opposed to having this fragmented NFTs or fragmented components across chains. So these are things to consider when thinking about where you're going to deploy your NFTs. So that's high level. Let me check the chat real quick. Okay, I don't see any questions. I'm going to chat a bit about the actual technical specification of like the first NFT ERC 721 Ethereum proposal. So ERC 721 is like a pretty basic interface. I took the screenshot from Open Zeppelin, where they have a lot of good resources about different token standards. The basic interface required to be ERC 720 compliant is pretty basic. And you might notice that it actually doesn't even support the metadata field. So you don't actually need off-chain pointers of metadata to make an ERC 721 contract. I personally haven't seen any contracts that do not have reference to off-chain data, but it's not technically required for the base implementation of ERC 721. But it's a lot of the base functions are just checking balances, ownership, approving, and transfers. And those are the basic pieces. And then there's additional in addition to metadata, there's also additional components that you can add to ERC 721 that are outlined on that Open Zeppelin link. Joe will share the link to, Joe's actually going to share the link to this deck. So you guys can have the links to all these references that I have. But yeah, as I mentioned, there are different NFT standards, and there's actually very high profile NFT projects that don't comply to standards. CryptoPunks on Ethereum, probably the largest, most high profile project right now. That was actually developed before ERC 721 standard was written. So there is not, it does not comply to the ERC 721 standard. I don't recommend that you design a token that does not comply to a standard, because you get a lot of benefits by complying to the standards, like working with OpenSea or other NFT marketplaces will just work out of the box. There's no additional configuration. You can oftentimes in a NFT marketplace, you can just add the address of your token contract, your collection of NFT contract, and the marketplace interface will just read the token list, look up all of the metadata information needed, and just add all of this stuff automatically. So it makes it really easy to build scalable products there. But to be ERC 721 compliant, it must implement those basic functions around approvals and transfers. I'm also looking up token information. And I mentioned that many implement additional functions related to metadata. So it's specifically this function, it's called function token URI, and it just takes a token ID, token number, and it returns the metadata URL stored off-chain. And those are usually stored on IPFS or Arweave, which are decentralized storage. They're decentralized storage products. So yeah, one really important thing about these off-chain identifiers is that the data must be immutable. Like, because once you put this URL in your token contract and it's referenced there, you cannot change it. I mean, I guess you could design your contract to update the token URI, but that's not a good practice, because you want to have guarantees. Once you create a token, you want to have guarantees about what the contents of that token are. And if you allow the contents of that token to change, there are no guarantees there. So yeah, keeping your metadata URLs constant and uploading them to a persistent data storage service is important. In ERC 721, the metadata includes just three basic things. It includes a name, a description. So you have the name of the token, description of the token, and then an image. And the image is often just another hash pointer to another file location on IPFS or Arweave. I have a link here to the Open Zeppelin implementation of the ERC 721 full contract. Looks like I can't just switch tabs, but I definitely recommend you guys check that out, because this is a common contract used in a lot of projects that are deployed on Ethereum right now. And then OpenSea, the OpenSea marketplace has recommendations about what the NFT contracts that they support, like what that includes. It's actually interesting. They have some additional information around, like they have this idea of, so there's two additional fields. So it does include the basics of name, description, and image, but then there's this additional field of external URL, which is another, it's just the URL that will show up along with the image on OpenSea. But there's also this attributes field, which is just an array of attributes. So if you guys have been on OpenSea, you might see below an NFT, you can look up the attributes and the rarity and things like that. So this is common in like PFP projects where like in punks, the attributes are different in terms of like their hair, their lips, their eyes, their just all of their features are different attributes, and then they're procedurally generated. So there's a bunch of like random punks that are generated. So a lot of these projects will use the attributes field to include like what those features actually are. So jumping to the ERC 1155 contract. This is a newer version of a non-fungible token standard. And it's like informed by ERC 721 as well as some other token standards. Like I know ERC 777, which I think is a fungible token standard. But the big like innovation with ERC 1155 is it allows you to create fungible and non-fungible tokens in the same contract. You can see the base functions are similar to ERC 721, where there's basic like info retrieval functions as well as approval and transfer functions. But like with ERC 721, there's these additional contracts that you can use to extend the functionality of the base standard. So adding metadata, adding like enumerability, adding ownership, things like that. So if you have a use case where people may need fungible and non-fungible tokens, like I think blockchain gaming, I think there would be using an 1155 contract might be a better use for like a gaming product than ERC 721, because with 1155 you just have to deploy one contract and then you can manage a whole suite of tokens just with the 1155 contract. So yeah, I mentioned it's fungible and non-fungible, and many of, again, with 1155, like with 721, many of these contracts implement additional functions related to metadata. So in 1155, the function is just called URI, where you actually you pass it the ID of the token, like with 721, and it returns the metadata URL stored off chain, just like with 721. The metadata specified in 1155 is a bit richer than in 721. So it includes name, description, and image for each token, like with 721. But it also includes decimals. So if you have decimals, that indicates a fungible token. So that specific token defined at that ID will be a fungible token. And then there will be a balance associated with each account that owns part of that token. And then there's also this properties field. And properties is super flexible. So it can really be anything you want. You can define like JSON objects there that include a bunch of nested objects. So it can get pretty complex in terms of how a token is defined. So yeah, projects requiring multiple tokens can use one 1155 contract for all tokens. And then I linked to the Open Zeppelin ERC 1155 implementation there. I'm going to stop sharing for a second. And I'm going to pull up an example so we can just look at what this looks like in real life. So I'm going to pull up the let me just share one tab so you don't have to look at that giant screen. All right. So you guys may have heard of Bored Ape Yacht Club. It's another one of the biggest PFP projects on Ethereum. And I thought we could just go through and see how they actually implemented their token. So I'm on Etherscan, looking at Ethereum mainnet. and I'm looking at their verified contract. But it's actually pretty simple. It's verified, so I can just look at the source code here, but it's an ERC 721 contract. And I'm actually just going to go to read contract, and we can look at the functions that are available to it. Like a lot of these functions are defined in that Open Zeppelin standard. One thing I do want to point out here is like the base URI. This is an IPFS pointer. So if I look up the contents of this IPFS hash, we should see an IPFS folder that has all of the Bored Ape tokens in it, all of the data there. It might take a little bit because IPFS can take a little while. I think I'm routing through a gateway provided by Brave. I'm using the Brave browser where I can have an IPFS integration. There's a lot of functions around like approval, looking up specific tokens at indexes, but I really wanted to look at this token URI because this is where we can look at the metadata. So I'm going to query, let's say, token 25, and then it's going to give me back this base URI. It's still loading, but then it just returns the number of the token at the end of that. So I'm looking at a specific file, and it gives me this metadata. So this, getting the token URI points me to this metadata. And I can see there's an image and attribute. So there's actually not even a name or a description with tokens. It's just an image and the attributes. So let's actually look up the image here. Just copy this. And there's the image of the token. We look at Bored Apes on a marketplace or something. There's just a program behind the scenes that's fetching this information. Here's the whole list of all the tokens. I think there's 10,000 of them. It's pretty standard for PFP projects. But you can just go through and look at the metadata for every token here. So a lot of times when a marketplace is displaying NFT data, it's just calling the token ID function and getting the specific instance and then getting the metadata and parsing that for all of that. So yeah, that's pretty simple actually how it's working behind the scenes. Setting up programmatically is a bit more work, but I want to show how to easily deploy something like this using some simple tools. So you don't have to write a lot of code actually to create your own NFTs, since pretty popular in terms of like jump back to the token wizard. So I'm going to go through how to actually deploy some of these contracts. So I'm going to show you the token wizard. I'll show you some of the Open Zeppelin token implementations and the GitHub files associated, which you can just copy paste. And then you can deploy these using Hardhat, Truffle, or Remix. So like using the token wizard, and we have a page in our docs about this that I'll show you guys. This token wizard on Open Zeppelin is pretty cool. It uses their current like audited, published, written by professionals smart contracts. So you can interface with these in a way that you know will be secure, because there's many other projects that have leveraged them. And I just want to caveat this by saying like this has been designed for Ethereum, but it's really easy to just use these contracts and deploy them right to Celo. You can just actually click open in Remix, and it will pop this open Remix, and you can deploy using Remix. But I'll show you how to do that in a little bit. So this contracts wizard allows you to easily create ERC20 tokens, 721 tokens, 1155, as well as a governor token. I haven't messed with the governor token yet, but let's just look at the basic ERC 721. I can add, so like you can name your token. Let's just call it mobile crypto. NC token. Base URI is it's this base URL that we like with Bored Ape Yacht Club. I looked up the base URI, and it's just like the folder containing all of the token data. That's what you would put in this base URI. So that's stored in the contract, and then within that base URI folder, you're going to put a bunch of specific token metadata information. And then you can make your token mintable. Probably want to do that if you want to allow people to mint it. Otherwise, you can create them all yourself. You can make it burnable, pausable, all of these things. And adding URI storage adds this token URI function that allows you to point to metadata. So you can select the features that you want, and this editor will just add these right in the Solidity for you. And then once you have a token that you like, you can just click Open in Remix. And Remix is a web-based developer environment designed for EVM, deploying to EVM chains. So Remix is importing this code example right now. I don't know if some error flashed that I missed, but I have some examples here from previous demos that I did. Like this one is, I called it the Prosperity Factory. It's actually the one linked in our documentation, but this is populated right from the token wizard. So we do have maybe Joe could drop a link to the page in our docs about how to deploy using Remix. So you don't have to go over all of that right now. And you guys can reference it later. But essentially, you just compile the contract, go to the Deploy tab. You can select Injected Web3, which will connect to MetaMask. I've already authorized MetaMask to access this page. So this is, you can see, it's probably super tiny, but it says it's connected to custom network 42220. That's the 42220 is the chain ID of the Celo mainnet. So if I deployed this contract right now, it would go onto Celo mainnet. I just select the contract that I want. I called it Prosperity Factory, so I can click deploy. You guys can't see it, but MetaMask just popped open asking me if I would like to confirm this transaction. So confirming that would deploy this contract onto mainnet. So this is pretty cool, where you can just kind of mess with some of these options and then deploy contracts and see how they behave. I did want to just highlight this page on GitHub, where it's a link to the Open Zeppelin GitHub repo, where you can look at all of their token implementations. With 721, you can see all the options, like the base interfaces here, and then the extensions, like making it burnable, enumerable, pausable, URI storage. So these are all the options that you have in the token wizard, and these are just the implementations of it here. So you can actually just copy this source code as well and use your preferred method of deployment, just using these as the base. And yeah, I definitely recommend using the Open Zeppelin references, because these are they're very well documented on their site, so you can see exactly how it works and kind of why they're written how they are, and they're written by professionals. So yeah, the most common ways that I see developers deploying these contracts is through Hardhat, Truffle, and Remix. I just have a link here to a Hardhat example repo of how to set up Hardhat to work with Celo. And so when you guys have this, you can see. In this presentation, you can see all the links. So yeah, one more thing I wanted to cover here is after you deploy your contracts, in order to get a lot of the benefits of like marketplaces or like even in the Block Explorer, for the Block Explorer to be able to read your NFT token data, you're gonna have to verify your contract. In Remix, this is really easy to do. If you click this plugin manager tab on the left side, you can see all these plugins. I already have, I don't see my activated ones, but I already activated the Sourceify one. There's one called Sourceify. So I already activated it, so it's in my sidebar. Once you have smart contract source code in Remix, when you have this Sourceify plugin activated, you can set the network that you want to verify the contract for. So I'd want to pick Celo mainnet, and then I would paste the address of the deployment that I made, and then I'd click verify, and Remix will upload the source code and the metadata required to verify the contract to Sourceify, which will then, on the back end, also verify it on the Block Explorer. So then if you go to the Block Explorer and look up any NFTs, you'll actually be able to see the images of the NFTs right in the Block Explorer. And this makes it easy for other tools to reference your token data and things. In our docs, we have examples of how to verify your contracts using Truffle and Hardhat as well. I have a link to additional resources as well, where I have some links again here that I linked to throughout the presentation. Also some additional ones. I'm sharing the wrong tab. There's this cool resource called nftschool.dev that provides some more context around NFTs, the standards, why they're written how they are, and also some tutorials on how to learn more about building with NFTs. So IPFS and Arweave, the Contract Wizard, OpenSea standards, Remix, MetaMask. Pinata IPFS storage is an easy tool to upload files and folders to IPFS. So if you create a folder with all of your token data in it, you can pin it on Pinata and reference that Pinata data from your contract. The Unifty Marketplace is the most popular NFT marketplace on Celo right now. But it's also, I think, the only one that I've used. So NFTs on Celo are super new, and there's definitely a lot of room for building out infrastructure and key tooling for developers as well as end users. So these would be great hackathon projects. And then I mentioned verifying contracts with Remix, Truffle, and Hardhat. And these are linked to the specific pages in the documentation that show how to do it. So with that, I'm going to stop for a second. I'm going to see if there's any questions. And if not, like I did deploy that Prosperity Factory contract to Celo mainnet, so we could take a look at that. And I can show you exactly the tools and kind of how I did that. Which might be useful. So yeah, if there's no questions, I'll just jump into doing that. All right. I've got multiple browsers open with the different pages that I use to run this deployment. So I might be screen sharing and stopping a couple of times, but this page I'm showing Pinata. So like this is the first step that I used in like setting up this NFT deployment that I did. And I just uploaded a bunch of files, and you can see like a bunch of CIDs, which is like the IPFS hash of the content of this information. Let's just look at number 4 here. It's some trees. Let's look at 13. Some more trees. All these tokens are just trees. So it's all my NFTs on Celo right now. It's just a bunch of trees. But basically what I did was I uploaded all of this token data as images and just numbered them. The numbering is important because like when we looked up like the Bored Ape, it was like an IPFS folder hash, and then it was just a so it's like /1/2/3 up to 10,000. I think I only deployed 13 tokens here, or like set up the metadata for 13 tokens. So once I got all of the JPEGs uploaded to IPFS, then I needed to create a folder that contains all that token data. So I called that folder here the Prosper Factory metadata. And then you can see I have my IPFS folder here, and then I just have 14 tokens here, 0 through 13. And then each one of these is actual metadata that points to the image. So if we go back, let's go because I think we just looked at that one. So we can verify that. It's the same thing, same image that we saw. So if I open this image up, it's going to take a little bit going through the IPFS gateway. I'm actually running an IPFS node on my machine right now, and I don't have any of this information pinned locally on my machine. It's all posted on the Pinata pinning service. So we'll see how good Pinata is at sending me this info. Looks like it's going to take a little bit. But about the process here, the first step was uploading these images and then getting the hashes. And I actually had to set up the metadata files for each one of these. So in each one of these metadata files, there's an image tag that's actually pointing to the image hash. And then all of these metadata files are in the IPFS folder that I added. So once I have all of IPFS data set up, then I can actually go into the Open Zeppelin token wizard, and I can put this folder as my base URI. It would be like IPFS. It'll be like IPFS:// and then I'll put the hash of my folder as the base URI, and then I'll just the ERC721 enumerable. So every time a new token is minted, it will just increment the token ID. So it's going to start at 0 and then go up by 1 as each token is minted. And then there's only 13 tokens here, or 14 tokens. Could have to set a limit there. Looks like this is still taking some time to resolve, but let's look at a different one. Maybe it's just my local node is having trouble connecting. I'm also connected to a VPN right now, so that might be giving it some trouble. But this is pretty cool because with Pinata and the Open Zeppelin token wizard, I can actually create a set of NFTs without having to actually like write any of my own custom code. It might be helpful to write some scripts. Like if I have 10,000 pictures to upload and a folder to create, I'm not going to want to do this manually. And you could do it with a script, a pretty simple script. But it's not complicated. And then using the token wizard, put that base URI, make it enumerable, add the metadata information, and then deploy it. And actually, let me see if I can find the. I know I can find it. Since I verified my Prosperity Factory NFT on using Remix, I can actually look at the verified token contract. So you can see I created this contract. I've only minted 4 of the tokens. So like So else could go and mint their 10 tokens that are here. Let's look at the actual token, Prosperity Factory. I can look at token holders. It's just going to be me because I was minting all these tokens to myself. I can actually look at the inventory for this token. So ideally, the block explorer is going to load the 4 tokens that are here, and then show the images associated with each one of these tokens. There we go. So I've got token IDs 0 through 3, and then I can see the images of the tokens here, because the block explorer is just fetching this stuff from IPFS. So yeah, that's basic overview of NFTs, how to do some cool stuff with them. And yes, it should help you guys start exploring. Seeing the is there an option to have a user mint their token via a QR code? Yeah, definitely. So minting a NFT is just sending a transaction to the network. So essentially, if your users are using Valora or any mobile wallet, I guess it could be anything that scans a QR code. Basically, in that QR code, you just basically format a transaction signing request. You have to format that transaction to say, do a mint, call the mint function on this specific NFT contract, but it's definitely doable. Is there a way you can store a 3D print file in an NFT? So the use case is a user cannot gain access to the file unless they own the NFT in their wallet. That's definitely possible to do. If you have the 3D print file uploaded to IPFS, like this is definitely a good caveat for anything you put on IPFS. IPFS is a peer-to-peer network, like it's distributed, so you can't really restrict access. So if you put something on IPFS, it's going to be publicly accessible as long as people have the hash indicates where it's located. So if you put anything on IPFS, people can get to it without you restricting access to it. To get around that, like you could upload encrypted information to IPFS, and then people can access that encrypted information, but they can't decrypt it, so it's not really useful to them. But if you want token gated access, probably the best way to go would be have your 3D print file on a server or something that's not publicly accessible, just like a private server or cloud storage that has access control. And then to give them access, basically they will need to log in with a wallet, and then the application can read the contents of a user's wallet and be like, oh, they have an NFT that should give them access to a specific like restricted area, and then they can do it that way. So yeah, it's definitely possible to do. Putting the file that you want restricted on IPFS as an NFT is probably not the way to go. Yeah, because anything going on distributed storage like Arweave or IPFS is going to be publicly accessible. I hope that answers your question. Cool. If you guys have any other questions, we still got some time. Otherwise, it was great to show you guys around and show you what I've been thinking about the past couple of weeks, just like digging more into NFTs as the hype is still going, and yeah, people are deploying new projects and getting pings from people in my local area now that want to collaborate on NFT projects, and starting to launch digital art studios, people that didn't think they could do it or didn't have reason to before. So it's pretty cool to see NFTs getting a bunch of people that I would not have thought would be interested in crypto. getting them interested in crypto. So it's been really fun to learn about and start playing with. And yeah, if you guys have questions, ping me at Josh C on Discord. Again, I host office hours on Tuesdays, Wednesdays, and Fridays. I'm hosting an office hours tomorrow morning, 10 a.m. Eastern time. The event details are in the events tab on Discord, which is at the top of the channels list on the Celo server. So yeah, I'll see you guys on Discord.